You are going live now. Hello, space enthusiasts. Once again, welcome back to all of our budding astronauts and astronomers of the future. Once again, we have one more powerful NASA power up. This time, we are going to Mars. I hope all of you are ready. And here today, we have with us Ravi Raja sir. Ravi Raja sir is currently working as scientific officer at GP Birla Astronomical and Scientific Research Institute in Hyderabad. He is responsible for conceptualizing and designing of science exhibits, planning planetarium shows, organizing workshops on popular lectures and training sessions, and also other outreach programs at the center. Alongside, Ravi Raja sir is also working on his PhD thesis centered on studying the closed binaries with tertiary components. To achieve this, he utilizes the data from a range of ground-based and space-based observatories. His thesis work involves reducing and analyzing photometric and spectroscopic data of these closed binaries, as well as identifying any periodic variations that may indicate the presence of these tertiary bodies. Well, that sounds mouthful of words to digest, isn't it? But don't worry, Ravi sir is here to take us all through the exciting things on studying the binary stars and hide and seek the game of the stars, right? So hide and seek game of the stars. Okay, so once again, I welcome Ravi sir.
Yeah, thank you, Praveen, for introducing me to the audience. So,
So
good
Ravi sir,
evening, one and all.
it's your stage now. Okay, so thank you very much. Yeah.
Yeah, so thank you once again. So, good evening, one and all. So, I'm Ravi Raja Pothineni. So, I'm an observational astronomer, and presently I'm the scientific officer at GP Birla Archaeological, Astronomical, and Scientific Research Institute, Hyderabad. So, today I'm invited to speak on binary star. So it is basically my research field. So I will try to make it as simple as possible for you. So before learning about binary stars, let us start with some basic stuff. So let me share my screen for you. There is, I don't think I can share my screen. Ravin, hello.
Yeah, Ravi sir. Yeah, you have the
Yeah.
share screen option.
Actually, it
Okay,
says
you can share now. Yeah.
yeah, 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 got it, got it. Yeah, thank you. Can you see my shared screen?
Yes, sir.
Okay, I think it is a bit slow. Sorry for that. Okay, yeah, I got it. I think there is some connection issue, I guess. Just a moment. Right. Is it visible now? Yeah, I guess so. Is it visible? Is
Yes, yes, yes.
Yeah, yeah. Thank you. Yeah, okay. So let's start now. So before learning about binary stars, I just want you to I want to introduce something about light because light is like very significant to astronomers because the whole research, okay, in the field of observational astronomy depends on light, whatever the light we collect. So telescopes are very much important for us. The same way the light we receive from the stars is very much important and very significant. Okay, because it carries a lot of information from the stars. Okay, so let me say you something about light first. Then we will see how it is significant to us. Then we will go to the binary stars. Okay, so let's start. So light and astronomy. So we astronomers rely heavily on light, okay, for our research because it is a primary source of information. That is the only thing we receive from the stars, right? So we use the light to study celestial objects. We use different wide variety of instruments like telescopes, and they are connected with detectors. And we also use spectroscopes to detect the light and analyze the light. So once we collect the light, so we analyze it. So once it is analyzed, we get different information from that. Say, for example, the temperature of the stars. So how we determine the temperature of the stars? Maybe some of you may know it. So we use colors to determine the temperature of stars, right? So not just that, if you collect spectrum from a star, so you can make use of that spectrum to determine the temperature also. And another important thing is the chemical composition. Each and everything, okay, in the whole universe is made up of chemicals. Hope you know that. I need not say about it, right? Everything is matter, right? So this chemical composition of each and every star differs. So some stars may be some stars may be like sun, some may be like bit old, some may be bit like young. So each of them are different, each of them are unique. So in order to understand their chemical composition, we collect the light from those stars. So light is very significant for that reason only, and not uh, not just that. So in order to determine the distances to those celestial objects, okay. So I don't know. Maybe some of you know about trigonometry, right? So we have something called as parallax. So making use of trigonometric parallax, we determine the distances to the stars. And not just that, so once you get the distance, you can understand the motion of stars, which is very much important in understanding the space velocity of stars, which for which like for which the basic the radial velocity and proper motion of stars can be understood. So not just this, there are many other parameters which can be determined making use of light from the stars. Okay, so I have put some parameters here which are like pretty much important for me. So, but along with this, I think moreover, like significant discoveries have been done in astronomy, like the existence of black holes has come into picture, then a universe expansion. So Edwin Hubble. So from his observations, we got to know that universe is expanding at a certain rate, and that constant is called as Hubble's constant. So likewise, light plays a crucial role for astronomers in studying the whatever the celestial object we are observing. So it plays a like really very crucial role. It is very much important. Now let us see how the same light plays a key role in studying binary stars. So let's see now. And before jumping to that, sorry, I forgot to show you. So here at the bottom, you can see the spectrum of a star. So it's a continuous spectrum. This is just part of it. It is a visible region. So where you have VIBGYOR. So I think you know that, right? So whenever white light passes through a prism, you can see light undergoing dispersion. It splits into 7 components. So the same is shown here. But don't forget, it is beyond that. So electromagnetic radiation is beyond visible region. So you have ultraviolet, X-rays and gamma rays on one side. You have infrared, far infrared, microwaves, and radio waves on other side. So each of these plays a key role in the field in different fields of astronomy. So you have radio astronomy, you have X-ray astronomy, you have gamma ray astronomy also. Because in this whole universe, we have wide variety of celestial objects which emit light strongly in particular wavelength. Okay, so that's the reason we have specific regions to study in astronomy. So myself, I work more in visible and infrared region. So there are other fields where astronomers study the same celestial objects in various regions, like in radio. Some will study the same source in ultraviolet, some study will in X-ray and gamma rays, because each of these regions give us some specific information about these stars. Okay, now let us see what are binaries. So why are they important? Most of the people don't know that whenever you look at the night sky, you see many stars, right? And majority of those stars which you are looking in the night sky, they are binary stars. At least they are part of binary system. And there are other stars which are part of, they are not just part of 2 stars. There will be multiple stars in the system. There are tertiary, there are quadrants, there are more than 4 also. So such systems are there. So majority of the stars, what we are looking at, so are binaries. So the study of binaries become a significant area of astronomy, and it is one of the oldest areas which is like still open for research. Many questions, many things, whatever we observe, still many questions pop up. Many models are there. Still, there will be developments every day. So it is one of the active fields in astronomy. Now, what is a binary system? It is very simple. So whenever 2 stars orbit around common center of mass, so that can be considered as a binary system. Now, how do they orbit around a common center of mass? So it is because of the gravitational pull. Because each of these stars have some mass, and we know whenever some mass is there, obviously they exert gravitational pull on each other. The same thing happens here also. So we have 2 stars. So where each star will be exerting gravitational pull on one another, which makes them to orbit around common center of mass. So what is this common center of mass? So center of mass, some of you may know. So center of mass is very simple. So where the mass is assumed to be concentrated, it is like a balance point. Okay, to make it like bit understanding. Okay, So around that center of mass, so both these stars will be orbiting. Okay. And why these systems are important? Why these systems are interesting? The reason is these systems allow us to study the properties of stars in a unique way. Why and how? So you can see there like the photometry and spectroscopy. Photometry. So what is photo? Photo means light. Metry is measurement. So whatever the light measurements we do, we call it as photometry. Very simple. And spectroscopy. Spectro means spectrum, light spectrum. Whatever I have shown earlier, electromagnetic spectrum. So it is that way. So you get to know the chemical composition of the stars. So these two are very much important for us, the photometry and spectroscopy, because these two studies provide really a great insights into these systems. If you take example of photometry, I'm just giving you one example. I will be showing you that interesting feature very soon. So what we do is we try to collect the light from the star and we plot a simple graph, time versus the change in the brightness of the star. So that gives me some information about that star. And specifically, as I'm speaking about binary stars here, so in binary stars, generally these two stars will be orbiting around each other, right? So whenever they are orbiting around each other, if they are along our line of sight, so they will be eclipsing one another. So such binary stars are called as eclipsing binary stars. And my interest is those because they will be providing me direct information about the nature of the stars and whatever the physical processes which are going on. So I can study it like more easily. And the photometry becomes reliable whenever the system is exactly along our line of sight. If the system is not along our line of sight, then photometry becomes less reliable. In that case, we go for spectroscopy. Okay, don't worry, we will see how we do that and all. So just keep listening. Okay. Now, once we collect the light from the stars, say for example, binary stars, what do we do? So as I mentioned earlier, we plot a graph called as light curve. So it is called as light curve. Time versus variation in brightness is plotted on that. So whenever one star is orbiting around another star, so obviously there will be change in the system's brightness, right? So sometimes the brightness will be more, and whenever stars are eclipsing each other, the brightness will reduce. Now we will be making uh, the orbital period. Sorry, yeah, orbital period of the binary system. We will get to know their relative sizes. We will get to know the inclination of their orbits also. So that is like very much important for us, right? And not just this, we can determine the temperature also, not using light curve, but using the color. Why color? Because as I mentioned earlier, so you have seen spectrum, right? Each of the color represents a particular wavelength. You'll be learning more about wavelength in your courses, one of your courses. So wavelength, each wavelength will be a particular frequency. It will be having a particular frequency. So it will be having a particular temperature also. So whenever I collect light from two filters, like say one in visible and one in infrared, so the difference between these two filters give me the temperature of that star, how beautiful it is. What I'm doing here, I'm collecting light in the visible region, and I'm also collecting the same light in the infrared region. Now I have a particular measurement here in a particular wavelength, and I have another measurement in another wavelength. So now subtracting these two gives me what? One of the important parameters of star, that is temperature. Why temperature is so important? Because once we get to know the temperature, we can speak more about its chemical composition, and we can also determine various. I mean, especially its position. We will get to know whether it is a main sequence star, and it also helps in determining other parameters. Okay, let me show you how. So Yeah. So why binary stars? So before like knowing more about photometry and spectroscopy, let us see why these are very much important. As I mentioned earlier, so binary stars are very crucial in helping us understand the physical properties of the stars. And majority of the stars are binary stars. That is very well known. But whenever you have a single star, how many of you know that we cannot determine its mass directly for a single star? If there is only one star and there is no exoplanet, there is nothing which is orbiting around it, we cannot determine its mass. But without knowing the mass, how can you interpret its age? How can you interpret its evolution? It is not possible, right? Then comes this binary stars. In binary stars, since one star is orbiting around, one around another, so we can make use of something called as Kepler's laws. I think most of you might have heard of Kepler. So we have something called as Kepler's third law. So making use of Kepler's third law, as I know the period of the binary from the light curve, right? And I know the separation also because it is very easy to determine it. So now I have period and the separation. So making use of Kepler's third law, I can measure the mass of the stars, but I will get the total mass of the system. And analyzing the light curve, I get the mass ratio, something called as mass ratio. So you have the total mass and the mass ratio of the components. Now you can determine individual masses of each stars. Now you may get one question. What if the star is single star? So determining mass of individual components of a binary system, how does it help in understanding a single star? Yes, it will. So whenever you have two binary, in a binary star, we have two stars, right? So making use of this logic, Kepler's third law, we are able to determine the mass of a star, though it is part of a binary system. But don't forget, this star will be having its own temperature. It will be having its own size and mass. Now, what I will do is, I will now measure the temperature of a single star, and now I will compare that with that of this star. That's how I can estimate the size of the individual stars. So whenever you go, just Google it. So whenever you search for any single star's mass, there will be a huge error bar. Okay, there will be a huge estimation. So the reason is this: if it is a binary star, you get to know the masses very precisely. But for a single star, which does not have anything around it, so it will be a bit hard for us to determine its mass. So we have to compare it. We have to estimate it. So that is how estimates work. Okay, not just this. So once you get the masses, you can understand the physical process which are going undergoing in it, because physical process govern the behavior of the stars. Okay, we will see how. And not just that, since these two stars are part of a system, over a period of time they may come close. Again, they may go back. Sometimes they merge also. So in order to understand this type of processes, so studying binary stars becomes very important. So we can understand the evolution of stars. So binary stars become like a tool for us to test the evolutionary models also. So in astronomy, so binary stars are considered one of the like say what we say fascinating and very significant topic, because they help us in understanding and determining many things. Okay, we will see uh, what are they. So now we have different types of binaries. I don't want to speak much on this. So we have visual binaries, spectroscopic, then we have astrometric and eclipsing binaries, because my specific interest is eclipsing binaries. So visual, the name itself says. So whenever you look through a telescope, you can see two stars which are very close to one another. So such binaries are called as visual binaries. The name itself says visual. Visual means what? So whenever you look through a telescope, you can see that they are very close to one another. The next one is spectroscopic. So spectroscopic binaries, you cannot resolve or you cannot, even if you use a telescope, you cannot say that they are two stars, but they are two stars. Then how we get to know? By taking the spectrum of that binary. So whenever you take the spectrum of the binary, by analyzing the variations in the spectral lines, we can say that there are two stars in the system. So such type of binaries are called as spectroscopic binaries. Next is astrometric. So the presence of second star in these binaries, mostly they will be white dwarfs. You might have heard of white dwarfs. So sun, once it ends up, I mean, it's hydrogen and helium, it will end as a white dwarf. Okay. So by analyzing the wobbling, because of the strong gravitational pull, so there will be wobbling effect. So because of that wobbling effect, you can determine that there is a second star. So those binaries are called as astrometric binaries. And finally, we have eclipsing binaries. Now, what are these eclipsing binaries and why are they important for us? So the name itself says eclipsing means what? One star passes in front of another star. Okay, I will show you the light curve. Then you will be understanding it. So you can see it here. There are two stars here, right? So there is a very big star. So you can consider it as a massive star, and there is another one which is less massive, or it can be vice versa in some cases also. Don't think that if it is very big, it is always massive. It need not be. That is why binary stars are very interesting. So here, what is happening exactly? So there are two stars in the system. Whenever these two stars are eclipsing each other, below you can see a graph where the brightness is reducing. So whenever the small star is blocking the large star, so you can see a large dip. Okay, I think you can see the graph clearly, right? So please look at the graph which is just below that. It is brightness, I mean time, brightness versus time graph. So whenever it is eclipsing the larger one, so you can see a very big dip. And whenever the big one, okay, the primary star is blocking the smaller one, you can see a small dip. This is called as light curve. Now you may get a question. How does this help you? Yes, it will help us a lot. Depending on the dips, the change in the variation of brightness, it helps us in determining the relative sizes. Helps us in estimating the orbital period, which is very crucial for determining the masses of the individual stars. How beautiful it is. Now you may get out. So how we can directly get to know the masses or sizes? We never get to know anything directly. Once we get this light curve, we will make use of some models to fit the model onto the observed light curve. I will show you very soon whatever the results I got during my research work. So this is called as light curve. So this becomes a crucial part. This is very much important for us. Okay. So now coming back to eclipsing binaries. So hope you understood what are eclipsing binaries now. So where one star is partially or totally blocking the light of another star. Okay. So these are very much important because so we get information about the individual stars which are present in the binary, and there are different types of eclipsing binaries. So, oh, sorry, I think yeah, here it is. So we have different types of eclipsing binaries, like say detached, we have semi-detached and contact. Now, what this has to do with it? So, as you have, I mean, since I cannot see these stars directly, light curve is the only tool which help us in understanding the nature of the eclipsing binary. So, depending on the shape of the light curve, most of the time we say that whether it is detached or semi-detached or contact. What are detached systems? Detached means the two stars are clearly away from each other. They are just gravitationally bound. They are happily revolving around each other. They are very clearly away from each other. Now, what is semi-detached? Semi-detached means among these two stars, one of them will be evolving. So what happens whenever a star evolves? What happens if sun evolves? I mean to say after 10 billion years, it will expand, right? The same thing happens here also. So one of the stars expand and it will transfer its mass to the other one. So such type of eclipsing binaries are called as semi-detached. The previous one is detached. Now it is semi-detached. Now in some cases, what happens, both of the stars, they come very close. They mutually share common envelope. So these are even more interesting objects. So such objects are called as contact. You believe it or not, these contact systems are very much important because if you study these systems, you will get to know whether the stars will merge or not. Or, we will get to know something about like blue stragglers. There are something called as blue stragglers. So we'll get to know more about blue stragglers. Okay. So studying these three types of binaries help us in understanding the evolution, their formation and evolution also. So the light curve of an eclipsing binary tells us about the information about the period, the masses, relative sizes, and the spectrum of the binary stars help us in understanding the chemical composition, ongoing magnetic activity. I don't know how many of you regularly follow news. So recently we have seen, like from the past few months, sun is like very active. There are many active sunspots on the surface of the sun. You believe it or not, we have published a paper recently. So we have determined some ample sun flares similar to sun flares or solar flares. We have determined stellar flares on those stars. Those stellar flares are at least a million times powerful than the sun. So sun ka solar flare energy will be around 10 power 27 arc. But whatever the solar stellar flares we have observed in the test observations, we make use of test data. So in that, those stars are very active, magnetically very active. So the flaring which is happening on those stars, they are at least like million times to billion times greater than that of the sun's activity. Just assume having such stars in our solar system instead of sun. Just think that what happens if a binary system is there. Just think, this is another research problem. This is one of the interesting research problems because if you have a binary system, can a planet exist around it? If it exists, how much close it will be? Will it be orbiting only one star or will it be orbiting both the stars? What happens to it? What happens to its fate? And not just that, another interesting thing is this small object, whatever it is, exoplanet or another star, it can decide the fate of the binary system, you believe it or not, by removing the angular momentum from the system. Don't worry, you will be learning about angular momentum very soon. So angular momentum, probably you know about linear momentum, right? So the product of mass and velocity. Similarly, whenever stars will, not just stars, any mass which will be revolving or orbiting around itself, so it will be having angular momentum. So since there are two stars which are orbiting around common center of mass, so due to the variation in the motion of the objects, so there will be change in the angular momentum. Okay, right. So coming to photometry of eclipsing binaries, so here you can see some results I have posted here, right? So what we do is once we collect the data, so we will get the light curve. So now my job is to fit a model to that light curve. So once I fit a model to that light curve, okay, I will be getting some basic parameters. So making use of those parameters, I can determine the secondary temperature of the star. I mean to say temperature of the other star, because for any given binary system, most of the time we will get to know only one star ka temperature. So by modeling it, so we'll get to know the temperature of another star. So how beautiful it is. And also we'll get to know its luminosity, relative sizes, and we will get to know its mass ratio also. So I have presented our recent results here. So here this system's inclination is 85 degrees. 85 is almost like 90, close to 90. So whatever results I got here, it is like more reliable. Just beside that, there is another system where its inclination is just 63 degrees. So whatever the values I have determined here will be less reliable in this case because the inclination is just 63. As I mentioned earlier, it should be close to 90 degrees. Okay, this is how photometry works. So once you get the light, fitting a model to the light curve helps you in getting these parameters. Okay, and sometimes stars will be like very active that there will be sunspots. Like sunspots, we have stellar spots on those star surfaces. So they help us in understanding the ongoing magnetic activity. And coming to spectroscopy, so spectroscopy is the most reliable study for any given subject, especially in the case of eclipsing binaries. So spectroscopy helps us in determining not just temperature, but also chemical composition, and also whatever the physical processes which are happening. Because if you take the spectrum of a star, if you compare it with any standard star, whatever the variation you see in the spectrum, that helps you to understand what is happening on that star. You need not see it directly. The light which is coming from those stars itself says what is exactly happening on those. So whatever the magnetic activity which is happening, so that can be understood just by looking at its spectra, just by looking at its light curve. So don't think that astronomy research is so tough. It is very easy, especially observational astronomy. Only thing is you should have a good high precision data collecting instrument like TESS or any space telescope. You have some ground telescopes also. So even they give you wonderful data. Only thing is you need to collect it continuously. Only you should get the time and you should observe the source for some period of time. So we have some national facilities like Himalayan Chandra Telescope. We have Vainu Bappu Observatory in the state of Tamil Nadu. So these are some facilities. There are many. So I'm specifically saying about the ones which I regularly write my proposals for. Okay. So once we get the spectrum, we try to analyze different lines which are present in the spectrum. There will be some absorption lines. There will be some emission lines. So absorption means, so there you see a dark line on a bright background. Emission may you see a bright line on a dark background. Okay, so now how does it help you? You may ask this question. So it helps us in understanding what is happening exactly in the star, what chemical composition is there, and how it is changing. I mean to say, over a period of time, if you observe it continuously, you will get to know how the ongoing magnetic activity is changing. Okay, but please remember, we don't get to know this just in a single day or in a single moment. If you want to understand that particular binary system, you have to observe that binary system for a period of time. Then only you will get to know what exactly is happening on that binary system. That is the reason you can see observations for these binary stars right from 1800, say 1900, 1900, say till now. 1800 in the sense like very prominent ones, very bright ones only. Now, what I do exactly? I do both photometry and spectroscopy. And along with photometry and spectroscopy, I will also specifically work on the period variation. Now, what is period variation? As I mentioned earlier, these eclipsing binaries are very interesting objects. So, due to, especially in the case of semi-detached binaries and contact binaries, so due to the mass exchange, okay, one of the star may exchange the mass, or both of them will be having a common envelope. So because of this, there will be continuously ongoing magnetic activity. And sometimes the systems are known to host third bodies or say additional components. Now, what does this additional fellow do? He won't stay remain quiet. So whenever he is revolving around this binary system, this fellow kicks out some angular momentum from the system. Whenever some angular momentum is removed from the system, the stars will be moving close to one another. And vice versa, both things may happen because some of the third bodies will be very wide, very far from the binary system. Some will be moving in eccentric orbits. I mean to say elliptical orbits. Some will be in circular. So due to there are various things we have to consider here, but presence of a third body helps us in understanding how these systems might have formed and how they evolve. You believe it or not, if you calculate the age of some binary systems, it goes beyond the age of the universe. What is the age of the universe? So the as of now, the rough calculation put it's around 14 billion years. But if you calculate age of some binary stars, So it goes beyond 14 billion years. So will it be is that really possible? It's a question mark. So how to understand that? How to suggest or how to what we say support your model? Because age of the it cannot go beyond age of the universe, right? Because age of the universe observationally is around 14 billion years. But how can your system can have age beyond that? So how to understand that? So these binary stars put a question to evolutionary models. So that is the reason this subject is always active. And I here you can see two graphs, right? So these graphs help us in understanding whether there is a third body in that system or not. If you look at the second one, you can clearly see there is a curve. It looks like a sine curve. Okay, yes or no? It is like falling again, rising and falling. Means the system is continuously undergoing period change. Period change in the sense what? So whatever the speed with which they orbit, it keeps on changing. Why does it happen? It happens due to various reasons. One due to magnetic activity. The second one can be due to the period variation. I mean to say due to third body. So these two are primary reasons which are responsible for such feature of a binary system. So we have analyzed it. And for the first one, if you see here, uh, I have approximated the mass of a third body. I mean, we have suggested the presence of a third body around that system, and we have given the value of the third system, I mean, the mass of the third system to be 0.51 solar masses. Okay, zero point 0.5 in the sense like half the size of the sun. So we have suggested there is I mean, another star which is present in that binary system bit far from it, like say around 5.28 astronomical units. Hope you know what is an astronomical unit, right? It is the distance from the sun to the earth. So it is around 5 times far from that. So its mass is around zero point 0.5. And don't think that it is a single object. It need not be a single object. It can be a group, two brown dwarfs also. Brown dwarfs are simply failed stars. But I got a single one right now. So I have put it as 0.51 solar masses. For the second system, which is like very interesting, here you can see the mass of the third body, whatever we have determined. So it is around 73 Jupiter masses. It is how much? 73 Jupiter masses. And see how beautiful the variation is. So it is clear that surely there is a third body around this system. And it is published this year, and we are the first one who predicted the existence of third body with that mass, that is around 73 Jupiter masses. And another interesting thing is this system, whatever 73 Jupiter mass third body is there, it is also very active. How much active, every day around, I mean, in our study we got to know that every day it is flaring, almost like 2 to 4 flares every day. So that much activities. Now you may ask me a question. Sir, if it is flaring every day, it means it is very active. Yes, it is very active. If it is very active, how can you say that it is a third body? Yes, we have checked that also. So whatever yes, it is a very active star, though, even though it is not enough to cause this variation. Yes, I say that it is very active. That is for sure. It is very, very active star. Not caused because of the present, I mean, ongoing magnetic activity. Surely there should be another third body, I mean to say another star or something in the system. Here we found it to be a brown dwarf. 73 Jupiter masses is a brown dwarf. So this brown dwarf is a failed star. There will be nothing happening in that inside its core. It is just like a very big Jupiter, big brother to a Jupiter. So this is what we have determined. So this is what I work on. So probably some things you may not understand, but what I want to say ultimately is light. Light is very crucial for us. It is like very important for us. So whatever the light we receive from a star, this is how we do the research. whatever the each photon we receive from a star, it is very crucial for us. Okay, what are the detectors we use to collect that? Okay, so the time for which we collect the data, it is very crucial. So space telescopes like TESS, Kepler, and JWST, which is like very recent one, you might have heard of it. So these telescopes help us a lot in uh, studying these binary stars because they provide us with high precision data. So those instruments are really good. They provide really very compatible data, very good data. Okay, so that is the reason we are able to do this research. Okay, and whatever the cycles you are seeing here, it is not a single decade or not a single year. It is for at least 10 to 20 years. So whatever the curve you are seeing here, it is not of a single year or a single day. It is not like exoplanet. Even in the case of exoplanets, some of them have periods years. So here also, whatever you are seeing here, it is for 2 decades. I have collected 3 decades ka data and I have worked on it. Then only I have seen this type of variation. Okay. So that is the reason if you observe any object for longer duration of time, you will get to know more about it. And don't think that whatever the values we publish they are like fixed. It need not be. If you get a better telescope tomorrow, a better instrument tomorrow, obviously these values may change. Okay, there will be minute changes, but still. So whenever your light collection becomes more and more worthy, if it becomes more and more high precision, so then obviously the research also becomes more and more reliable. Hope it is clear. So as of now, binary stars ka research, like there are many other groups throughout the world who work in on different types of binaries also. So this is what we generally do, and specifically I do. Okay, so yeah, with this I will conclude. So if you have any questions, you can ask now. Hope you have learned something new. And if you have any questions or queries or any suggestions, you can drop an email to me. If you want any additional material regarding any of this, you can just leave a message. I can provide it to you. Yeah, if you have any questions, I think we can take few questions. I think it
Yes,
is,
sir. Thank you very
I
much,
think
sir, for your insights into binary star system. So
yeah,
there is a lot of information I think that our students understood what kind of research happens
hopefully.
exactly, and what kind of telescopes and how the data actually looks, because our students may see always the very interesting graphical images of the binary stars and all, right? So they never look at the graphs, or the actual
Yeah,
data
yeah.
that it may be looking boring, but actually this is how the science happens. Okay.
Yes.
So
In
so this
true
is,
sense, actually, this is very boring because
yeah,
generally people expect very what is a NASA fantasy ka images and all, but we never
yes,
get that. We get only black
exactly.
and white images.
So this data will be taken by artists, obviously the thinkers and creators. So they will convert
Yes,
into very, very
agree. Yeah.
interesting stuff so that everybody can understand. Yeah, so I hope students got pretty good idea what happens behind the scenes, right? And
That's
so
true.
now we got some interesting questions, sir. Ran asked, actually, Ran asked that what is photometry and how do I do it?
So photometry is simply collecting light. Okay. So you will be using some instrument like telescope. You should have a detector. Detector means CCD. You can search something on CCDs. You will get to know. So if you have CCD, a pretty good telescope, go to outskirts where there is no light pollution. Fix your detector to your system, whatever, or directly to the telescope, and start observing any star. So photometry is simply collecting the light from a star. Your eye is a detector, but your eye cannot store the data, right? It is very like, persistence of eye is like 1/16 of a second. So you cannot store anything. Okay. So, but that's the reason we are using cameras. We are using CCD is more or like a camera. So you should connect it to your telescope and collect the data from any star and plot it. Then you will get to know. It is very simple. It will give you the electron count. So plot it with respect, I mean, on x-axis take time and y-axis just plot the variation in brightness or magnitude, whatever you consider. Then you will get to know what is happening to the, I mean, in that star or to that star. Depends, yeah. So this is photometry. This is what we generally do. So it is simply collecting the light. That's it.
Thank you, sir. I hope it
Yeah.
answered Ran's question. And a lot of students think that, okay, what is the use of these graphs, X and Y that we learn? So here is the example, okay, how we can use these graphs in a
Yes.
real sense to do research like this. Okay, that's very nice, sir. And we have one more question from Yusufuddin. He says,
Yeah.
so what is spectroscopy?
Yeah. Spectroscopy, like photometry, may we collect the light directly. Here, what we do is we use some dispersion medium. Okay, you can call it as grating. I don't want to put some complex words here. So, what happens if a light passes through a prism? It splits into seven colors, right? So, here also, what we do is in the photometer, we collect the white light directly onto a detector. Now, instead of letting the white light directly to fall onto the detector, what I do is I introduce a dispersion medium in between. Okay, when I do that, now the white light split into those seven colors. Specifically, I'm speaking about only visible region. Now, once it splits into the seven colors, okay, this light is not coming from where it is coming from a star. Now, I what I do is once I get the spectrum, I see if there are any dark lines. Dark lines represent absorption, and then I see if there are any bright lines. It represents emission. So depending on where I am getting those absorption and emission lines, I mean, they will be at a particular wavelength, right? So based on that, I will get to know what composition is there and what is exactly happening on that star. I will get to know whether the star has sunspots, I mean to say stellar spots, or is it flaring, or is there any other process which is happening there? Okay. So yeah, this is spectroscopy basically. So you can determine temperature, you can determine masses of not exactly masses, but you will get a coefficient which can help you out in determining it. From the photometry, you will get the inclination. So making use of that inclination, you can determine the masses. So what are the masses you measure from a spectroscopy study that is more reliable than photometry? Because photometry depends on the inclination. Okay. So whereas spectroscopy does not depend on it, where inclination affects it, but still, yeah.
Okay, thank you, sir.
Only, yeah,
We understand that, okay, spectroscopy is some kind of a friend who helps us measuring a lot of things about the star without taking a
yes,
scoop out of the
exactly.
star, right? So we don't have to reach the star and we don't have to touch the star. We don't have to
Obviously,
take
yeah,
anything out of the star. So by just
yeah,
looking at us, from safe distance, we can understand many things from the
exactly.
about
Yes,
the
yes,
star. Okay, so
true.
thank you very much, sir, for insights into your research and the exciting field of binary stars. And I hope our students are very much excited to get into these kind of careers and they can apply the mathematics that they're learning, the physics that they're learning at the schools, right? So yeah,
Yeah,
so thank you very much,
we'll
students.
see.
And one more thing is
Yeah,
that before we wind up, I hope a lot of students have a lot of questions, but we have limited
yeah,
time. And after the session also, students can post their questions on our
yes.
community. So we have a community, right? All of
Oh,
our students are part of the community, and here they can post their comments. Okay, they can post their questions in the comment box so that we
yeah,
can take our questions to Ravi sir, and also
yeah.
our educators can
Yeah, I can
answer.
answer. Yeah, sure. Yeah,
Yeah. So thank you very much, sir. And all the
and
students,
thank
you
you
can
so
post
much.
your
Yeah. And I
yeah. Thank
thank Navas and especially Praveen Garu for giving me this opportunity. So I think maybe in near future, if I get more chance, so I can. I think I have to put it like even more simpler words because sometimes some audience will be like too young to know some of these concepts.
yes, sir.
So
Definitely.
I didn't get like much time to put the graphics and all. Next time I will try to put more graphics so that I can bring that complex into a simple ones so that you can look
Sure,
at the
sir.
graphics and understand it very easily. So thank you once again. So for making me part of this. So yeah,
Thank you, sir.
take
Thank you
care.
for your kind words, and it was our pleasure to have you on board, and definitely we'll have more like this in the future. Okay,
Yeah.
students, one more exciting news. You might be thinking, okay, why didn't we discuss about Martian spaceship? You're all excited about that, right? Okay, don't worry, keep that excitement alive. and we are going to see Martian spaceship. Okay, so we are going to learn about Martian spaceship and how to design one using Tinkercad. Okay, so keep your excitement alive, and yeah, so we have Space Week, right? So which is starting from tomorrow until October 10th. So in this Space Week, we will come with more concepts like Martian spaceship and also other guest lectures. Yeah, surprise. Okay, wait for the surprise. So keep excited and keep exploring, keep learning, and we'll come with one or two sessions in this Space Week. Okay, so to inspire you, and we'll bring more guests for you. All the best, students, and I will see you in the next session. Bye bye. Take care.